Okay, so coming down to it. Happy Friday. T minus 4 days. Right, Tuesday. So exciting stuff. As always, same old stuff for prep work. Hopefully checked out the demo. Hopefully continuing practicing, doing all the stuff, checking out the playlist on YouTube. All that good stuff that I constantly say every day. And we're just continuing to practice here. Right. So we have a couple questions left on this document or this file. I think, again, this is the long question here today, BC3. So I think this goes through H. I don't know if we'll get all the way through H. Maybe. But we'll just get as far as we go. And then whatever we have to finish up on Monday, I'll finish up on Monday. And then Tuesday will be the test. So the test is at like, what, 1, I think? But I don't plan on like teaching a class Tuesday morning. Obviously, you'll just be getting ready and doing whatever that you need to do for that. So no big deal. Okay. Let's go ahead and kick it off. So let f of x equal negative 2 over square root of x. Let a equal the series from 1 to infinity, where an is f of n. Okay, so this defines like 3 separate things for me. Like here's f, here's this capital A, this series, and then an is fn. Okay, so this series is a of n, but a of n is f of n, and f of n is based off of f of x. So it's just kind of like this chain of linking things together. This is all it's like a very complicated way just to write out that the series is this thing from 1 to infinity. All right, that's it. So determine whether the series from 1 to infinity of a of n and the series, but with this negative 1 to the n minus 1, converge or diverge. Explain your reasoning. Okay, so let's just start with this one. an, but again, an is fn, which is just f of x, but with an n, so negative 2 over square root of x, except I'm going to write this as x to the 1/2. Or actually, not x to the 1/2. Again, since we're talking about n, we'll do n to the 1/2. This is sort of looking like a p series to me. So let me pull out that negative 2. One over n to the 1/2. So this is definitely a p series. And I can just go ahead and state this series diverges. Explain my reasoning. Since it is a p series, where p equals 1/2, right, which is less than 1. Okay, remember, so when we're looking at p series, to determine if it converges or diverges, a divergent p series is if anything, this exponent is less than 1. Convergent greater than 1. So it's just about, like many of these things, they can go pretty quick as long as you are, well, drop my pencil. As long as you can recognize, oh, hey, this is looking like a p series. Let me try to switch it around so that I can do that, put it in that correct form. Right. So actually, I guess technically, any p value that's less than or equal to 1 is going to diverge. So there's the first part of my answer. All right, so secondly, we want to look at this series. N equals 1 to infinity. -1 of an, but I'll actually go ahead and write an is this thing. Okay. So what this looks like is it looks like an alternating series. Now, all we've done is take this an that we already had, but now we have this -1 to the n minus 1, which makes me think about an alternating series. Okay. So let's go through and do our alternating series test. So the first thing to look at is the limit as n goes to infinity of -2 over n to the 1/2. This denominator of n, even though it's being taken to the 1/2 power, that's still just going to be getting larger and larger and larger. The numerator is staying 2. So this limit is 0, which is the first thing that we want. Okay, when we do this limit, we just look at this part. We don't look at the alternating part. Okay, so that first check is good. Okay. One of the next things, what is, I forget the order that we usually did this in. Did we do the derivative next? Or, hold on, let me look. Not that it particularly matters. I mean, we could have looked at the limit last. It doesn't matter the order that you do these in. You just have to do them. But, whatever. I think the next thing, I can't find it. I think the next thing that we did was just look to see if it's greater than 0. Okay. And actually, it wouldn't be. I'm going to move this negative out in front so that I don't even have to worry about it. Okay, so that still keeps this limit the same. The next thing I want to know is this going to be larger than 0? So yes, it will be, because our denominator is going to be some positive number. It's going to be really large, but positive divided by a positive is always going to stay 0. And I'm allowed to do this where we can just pull out a negative. I could also pull out the 2 in front of the series, and it still wouldn't change anything at all. Okay, but just another example of manipulating things to make it fit with what we're trying to do. And the third thing is we want to know, is it decreasing? So let's look at the derivative of this, which I'm going to rewrite this as 2n to the -1/2. So that would be n to the -3/2. I lost my spot. Hold up. Okay. So third check, good. All right. So this series. So let me What was the original one that it asked? -1 to the n minus 1. Okay, converges by the alternating series test. Because, oops, I forgot my negative. I'm really struggling. Right, because when I take this derivative, -1/2 times 2 is -1. Right, so since this derivative is always going to be negative, that proves that it's decreasing. Okay. Sorry, I thought it in my head. That's why I made the check marks. So I was like, okay, yes, this is decreasing, but I just didn't write the negative sign. So we're good there. All right, so we did our 3 checks. And we've proved that this first series will diverge because it's a p-series. A p-series where p is less than or equal to 1. The second one we use alternating series test for. Part B. Oh no. Okay, consider the series from 1 to infinity of Bn, where Bn is f prime. Determine whether this converges or diverges. Explain your reasoning. Okay, so first thing I want to do is figure out what is f prime. So f of x we know is this. So let me rewrite that really quick as -2 x to the -1/2. Okay, and so if that's what f equals, then f prime would be x to the -3/2. Correct? Yeah, -2 times -1/2 would be +1. -1/2 minus 1 would be -3/2. So there's f prime. All right, so our series that we're looking at, for the series from 1 to infinity of Bn, which Bn is f prime, so n to the -3/2. So does this converge or diverge? Well, let me just go one step further in rewriting this. N to the -3/2 is the same thing as 1 over n to the 3/2. And hey, what do you know? This is just a p-series. So I just need to think about 3/2. Okay, what does that mean for me? All right, so we can just say this series converges since it is a p-series, and specifically since our p-value is greater than 1. Right? That's what it takes for a p-series to converge. That value of p has to be greater than 1. If it's less than or equal to 1, it will diverge. So again, another very quick problem, provided that we can recognize what we're looking at. Okay, so all we had to do was first take a derivative and then look at that series. And recognize if I just rewrite it as a fraction, it's a p-series. Oops. Part C. Consider Hn. Okay, so it just keeps defining new functions, new sequences. Hn equals 2 to the power of fn divided by f prime of n. Wow. Find the sum or show that it diverges. Okay, so I either have to, so first I just need to figure out, does it converge or diverge? Here's something interesting. From the start, this says do this or show that it diverges, think about the difference. The previous questions have asked us just does it converge or diverge. This one is potentially giving us the option to not just show that maybe it converges, actually figure out what the sum is. That should be a very large hint, because we only have one type of series that is going to be on this AP test where we can actually find the sum. Right? There's several different series that we can say, does it converge or diverge? But there's only one series that we can actually find the infinite sum of, and that's a geometric series. So I'm wondering if when I do this, I'm going to end up with a geometric series. Let's see. I don't want to speak too soon, but that's my guess. Okay, so first let me figure out what h is, because this is very... Okay, 2 to the power of f of n, which... Actually, let me just do f of n over f prime of n first. That way I don't want to have to write all that in exponents. Okay, so f of n divided by f prime of n. So that would be this over, what was f prime from my previous function? F prime was this thing, so n to the negative 3 halves, or 1 over n to the 3 halves. Okay, multiplied by the reciprocal. I rewrote square root of n as n to the 1/2. So this would be negative 2, 3 halves minus 1/2 would just be n. Right? So h of n just equals 2 to the power of negative 2n. So my series is 1 to infinity of h of n, which is 2 to the negative 2n. Negative exponents, typically it helps us to rewrite it. So 1 over 2 to the 2n. I could almost say this is geometric immediately, but I don't. There's the 2n in the exponent rather than just n. So, let me do this. Two squared is 4, so this would be the same thing as 4n. Right? 2 to the 2n is the same thing as 2 squared all to the power of n. It's just a property of exponents. So actually this is 1 over 4 to the n. And then actually that is the same thing as 1/4 to the nth power. And what do you know? As we suspected, this is a geometric series. All right, now it helped a lot that I was kind of expecting already to get a geometric series. I kind of knew what the form was that I was aiming for, because the problem asked me, actually, it gives me the option of actually finding the sum. We only have one series that we have a formula for that we can find the sum of for this AP test, and that's geometric. So this is a geometric series. To determine if it converges or diverges, we look at the absolute value of r. So r in this case is 1/4. Which is less than 1, right? So that means it converges. Now if I actually want to figure out what the sum is, we do a1 over 1 minus r. Okay, but this is a... Let's see. Yeah, I would need to go one step further here. Or do a slight rewriting. All right, to be in kind of the common, I mean, either one of these are common geometric forms. We just have to be aware of it. If it starts at 1 and it's just to the power of n, right, then this would give us our first term, second term, third term. But if we write it in this form, this is the form that's like the a1 r to the n minus 1, which it's what we kind of learned is the basis that we started out with. So my a1 is 1/4. 1 minus r is 1 minus 1/4. So that's 1/4 over 3/4. 1/4 times 4/3. 4's cancel. The sum is 1/3. And, you know, maybe if we want to write our answer a little more officially, so 1 to infinity of hn, that sum equals 1/3. Kind of a droopy infinity sign. I can't stop writing at like a diagonal angle on this. My straight lines are always kind of going up. Okay, so this is just geometric series. So we had to do a little simplifying at the start, and then it was just taking this series that we started with right here, change it so it's into the geometric form, and then I can actually use my formula for geometric series, a1 over 1 minus r. So we get 1/3. Part D. Oh, jeepers. Okay. Consider series of kn and mn, both from 1 to infinity, where kn equals mn times an. Jeez. If kn converges by the ratio test, where that limit equals 2/3, determine whether mn converges or diverges. Okay. Wow. That's a lot of stuff. Why? All right, but our goal, our end goal, is to figure out this series, whether it converges or diverges. Okay, so let's just start there. So mn is the same thing as, so kn equals mn over an. So let me just kind of solve this. So mn is the same thing as kn over an, right? Just divide both sides by an, and then let me use this now. Okay, so kn over an. All right, now what do we know about kn? I know that kn converges by the ratio test. Okay, that's interesting. Let's try using the ratio test then. Because we already know that the ratio test does work for kn, but what about kn divided by an? All right, let's do the ratio test. So this will be kind of gross. So remember the ratio test, we plug in n plus 1 divided by the original. And we take the absolute value of that. Right, so above this red line is just this, but with n plus 1. Below the red line is just this, but with n. Right, that's what the ratio test is. We divide them. We see what we get. If it's something that's less than 1, then we can say that it converges. All right, so now let's just do some simplifying. So kn plus 1 over an plus 1. I'm going to multiply by the reciprocal. I'm also going to do some rearranging here. Wait, why do I keep writing sigma? Sorry, not sigma. The limit. Really off my game here. I keep thinking it correctly in my head and then writing the wrong thing. Or maybe I just think the wrong thing all the way through. Maybe I'm just wrong, period. Let me rewrite this so that it is kn plus 1 over kn times an over an plus 1. All right, now the interesting thing that we know about limits is that we can split them up. Into the product of, since there's a product inside of the limit, I can split this up then as the product of two limits. And we already know that the limit, right, we know that kn converges and that limit equals 2/3. Well, that's exactly what I have right here. Right, so this is 2/3 times the limit as n goes to infinity of an over an plus 1. Okay, again, I had sort of a goal in mind already that I wanted to use the ratio test so that I could rearrange some stuff and end up here, because that's part of the information they give me, right? Most times that information they give us is going to be pretty critical in solving the problem itself. So if they give me this limit, well, then I want to try to make something where I can have this limit and already know that it equals 2/3. All right, so that's why I use the ratio test again, so that I could know this specific limit after I did some manipulating. Okay, so now time to actually do this limit now. The limit is n goes to infinity. An over an plus 1. Well, remember, an is the same thing as fn. And fn is just based off of f of x. So what will that be? So f of x, so f of n is negative 2n to the negative 1/2, just rewriting the square root as 1/2. And then since it's in the denominator, I'm just going to write it with a negative exponent. So then that means f of n plus 1 is just negative 2 n plus 1 to the negative 1/2. Okay, so let's try this out. -2 and -2, those cancel. N to the -1/2 and n plus 1 to the -1/2. So since they both have negative exponents, I can just switch their spots. So n plus 1 to the +1/2 on top, and then n to the +1/2 on bottom. Kind of a cool property about limits is that these absolute values and the square roots, well, so first off, there's a lot of steps for these. Since these are both to the 1/2 power, I can write this as n plus 1 over n to the 1/2. And then properties of limits tell me that the absolute value and the 1/2 exponent I can bring outside the limit. So infinity of n plus 1 over n to the 1/2 power. Now, the limit as n goes to infinity of n plus 1 over n. This should be something we could easily do in our heads. If I just plug in, infinity, I get infinity over infinity. So we would have to do a quick L'Hopital's rule. But look, derivative of the top is just 1. Derivative of the bottom is 1. So this whole limit is just 1. Right? And square root of 1 is 1. And the absolute value of 1 is 1. So this is all just 2/3 times 1, which is 2/3. And since we are doing the ratio test, what matters is that this is less than 1. So we can say the series converges by the ratio test. And I guess we should be more specific, since instead of just saying kind of vaguely the series, again, we have a lot of series here. There's Kn, Mn, all this other stuff. So let's be specific, since it asked us about Mn. So instead of saying so the series, let's say so. So the series from 1 to infinity of Mn converges by the ratio test. Again, try to not use vague pronouns. All right, use the specific names of the functions or the series or the sequence or whatever it is. Don't just say it does this. Be specific, because oftentimes there's a lot of pieces. Well, what? There's a graph, there's a table, there's a function, there's there's a limit. What is it that you're referencing? So name things specifically. That way you're sure not to lose points. All right, that was a lot of simplifying for that ratio test. You could probably do it quicker than I did. I was trying to write out the steps, a little more specifically. But I mean, potentially, depending on how comfortable you feel with limits, you could go straight from this step to this step. If you didn't need to think, oh yeah, that's all to the 1/2, the 1/2 and the absolute value on the outside, that's just 1. Okay, now you have to be careful. The more steps you skip, 1, you're not showing your work specifically, and 2, the more things that you just do in your head, the more likely it is that something gets messed up, right? You trip up on just one little thing. So while you don't have to write out every single detailed step of work, it still is a good idea to have an outline, a trace of what work you're doing. 1, because you have to show your work, and 2, because it's easy to lose track of certain details. All right, part E. Consider the series Cn. Okay, so now I have some new function where Cn is f prime over f. All right. Determine whether this series converges or diverges. So again, note the difference. This just asks converges or diverges. It does not ask me even to find a specific sum. If it did, I would be thinking, oh, I think it's asking me about a geometric. Something geometric is what I'll end up with. But here it doesn't. So I could still end up with geometric. Maybe it just doesn't want the sum. But again, just trying to emphasize the difference in how wording of a question can potentially give you clues as to what it is that you actually need to find. All right, so first let's figure out f prime of n over fn. So Cn f prime of n over f of n. Now, we've done this a few times now. For, let's see. Oh, yeah. Look, here's f prime. Here's f of n. Right? And potentially we've actually already even done this. We know that fn over f prime of n is negative 2n. So then if I want to flip that and do f prime over f, well, then it would just be the inverse of, the reciprocal of negative 2n. Now you could go through and do the work on that again, but I'm just using, since I already did the work, to do f over f prime. Then if I want f prime over f, not ep, f, then just take the reciprocal. And you should be good. Okay. So, and I actually don't even want the series of just this. I want the series of this, where it has Cn, but with the negative 1 to the n plus 1. Interesting. So 1 to infinity n plus 1 of 1 over negative 2n. But to make my life easier, I'm going to bring out that negative 1/2 in front of the series so I don't have to worry about it. So this is just 1 over n. Okay, so looking at this, I feel confident in thinking that since there's this part with the negative 1 to the n plus 1, that tells me that the series is going to alternate between positive and negative. I'm thinking I need to use alternating series test. If I could click extend page. Okay, so first up, so this is my an for the alternating series test. So the first thing that I do is the limit as n goes to infinity of 1 over n. That obviously is 0, so that's my first check. My second check is, will an be positive, greater than 0? Yeah. N is always going to be a positive number that I'm plugging in. So even though it'll be very small, this fraction, it'll still always be a positive number. So yep, we're good there. And then next is 1 over n decreasing. Well, let's take the derivative. 1 over n is the same thing as n to the negative first power. So that would be negative n to the negative negative n to the power of negative 2. So same thing as negative 1 over n squared. N squared will always be positive, but that negative 1 will always be negative 1. So no matter what n I plug in, the derivative will always be negative. A negative derivative means that it's decreasing, so which is what we wanted. So yes, decreasing. All three all three requirements for our test have been met. So we can immediately conclude that the series from 1 to infinity of, what do they call it? Again, name things by their proper nouns, or proper nouns like the actual equation or expression or whatever. Negative 1 to the n plus n Cn converges by the alternating series test. Okay, so that one's just based off of recognizing, kind of like the one we did before. If I have some part of the expression that looks like this, where it's a negative 1 to the power of, or some version of n, or n plus 1, or n minus 1, or whatever, I'm thinking about probably using the alternating series test. Okay, so if we're doing alternating series test, we can quickly, well, depending on the expression, we can relatively quickly go through these three checks. Is that limit 0? Is the expression larger than 0? Is the derivative negative, meaning that the sequence is decreasing? Part F. Consider the series from 1 to infinity of dn. Okay, so now we're defining some new series. Determine whether this converges or diverges. Wonderful. So now I have a composite function here. F of f prime over n. Interesting. So let's first see, what is f of f prime? Well, let me first write down so f of n I always do that. Okay, is this just rewriting the square root as 1/2, and then in the denominator use a negative exponent? So f prime n to the negative 3/2. Correct? Okay, yeah, positive minus 1. Great. So what we want to do is we want to take f prime and plug it into f. So f prime, so we're doing f of n to the negative 3/2. So that would be negative 2 n to the negative 3/2, all to the power of negative 1/2. Oops, and that's all over n. Multiply, we have an exponent of an exponent, so that would be, we multiply the exponents together. So negative 3/2 times negative 1/2 would be positive 3/4 divided by n. N to the 3/4 over n, so 3/4 minus 1 would be n to the negative 1/4. And then rewriting that as a positive exponent, so it would be negative 2 over n to the 1/4. Okay, so that's what dn is. So let's find the series negative 2 over n to the 1/4. This is kind of looking like a p series. So let me pull out that -2 in front. So it's just 1 over n to the 1/4. And yes, this absolutely is a p-series. Okay, so which is a p-series that, so we look at the exponent, n to the 1/4 power. So this diverges since p is 1/4, which is less than 1. Right? Remember, in a p-series, anything that's less than or equal to 1, it will diverge. If it's greater than 1, it will converge. So not difficult to do. The difficult part is just simplifying this first expression that it gives me, f of f prime. So just making sure I did the derivative correctly, make sure I plugged it into f correctly, and then just doing all that simplifying, right? The properties of exponent rules, simplifying the fraction, moving those exponents up or down depending on the negative and such. That's really the part that'll mess people up, that'll get you tripped up. Right, and then being able to also quickly do that type of simplifying. Okay, G. Consider G of Gn, where Gn is f inverse. Oh, that's interesting. Determine whether the series from 1 to infinity of Gn converges or diverges. All right, so first we need to figure out what the inverse of f is. You guys remember how to find inverses? Okay, so first if I just write y instead of f of x, and then we switch the spots of x and y, and then solve for y. So I'm going to multiply square root of y on both sides. Divide both sides by x. Square both sides. -2 squared is 4. X squared is x squared. You totally knew it. Totally knew what? How to find the inverse? So the inverse is 4 over x squared. Or not 4 over x squared, 4 over n squared. And almost the same thing. Look, this almost is just a p-series. I'm going to pull out that 4. So I just have the series from 1 to infinity of 1 over n squared, which again is a p-series that this one will converge, that converges since p is 2, which is greater than 1. Right, so since our value of p here was greater than 1, then it will converge. So again, easy. The calculus part is easy for this, right? Like for this part of the question, the hard part is just making sure that I get the right inverse, right? That was where the most work happened, was figuring out, okay, if this is my function f, then here's what f inverse is. So just can you get that? But once you have it, it's pretty quick work to manipulate it to make it look like a p-series that we can then just kind of immediately tell whether it converges or diverges. Okay, part H. Oh my gosh, this is the last part for BC for this question. Oh my god. Okay, JN. The calculus part is easy. The sentence I do not think I would ever hear or agree with. But it's true, right? At least for that part of the question. Well, but I've said that for over a year. I've said that back in analysis, right? Where a lot of times the new skill or the calculus part or the analysis part or whatever it was easy. The hard part typically is making sure you don't mess up any of the simplifying, the algebra, right? Expanding or dividing or simplifying things. Like, that's the part that really screws things up. Usually the rule itself isn't too bad. It's just a matter of, okay, can I use this now? But it's more complicated because the equation is complicated and I have to do a lot of simplifying or something like that. Forget negatives, yes. Reese does not believe that negatives exist for some reason. She refuses to accept. All right, Jn is f times f prime. Great. So f times f prime. Let's see, what was f originally? F is negative 2 n to the negative 1/2. F prime was n to the negative 3/2, right? Yeah, f prime n to the negative 3/2. So we've used this in like 3 different parts. All right, multiply them together. So Jn is negative 2, negative 1/2 plus negative 3/2. So that'd be negative 4/2, so negative 2. All right, so determine whether this converges or diverges. Didn't we already do this one from like part A? Maybe not. We had negative 2n. Okay, it's a little bit different. All of these are just starting to run together. Okay, so let's take this negative 2, pull it out in front. N to the negative 2, I'm going to rewrite as 1 over n squared. Check it out. This is yet again another P series. Where the P value is 2. So again, I will say, which is a P series that converges since P is 2, which is greater than 1. Honestly, that's what Whitmer always told us. I have a lot of questions. First of all, who is Whitmer? Second of all, what are you referencing? Third of all, no, I'll just stick with the first two. Flashbacks to Tyler Horton in math analysis. I remember Tyler Horton. I remember that kid. I don't. That's probably for the best then, RJ. You might be better off. So kind. That's really our entire calculus class is just so kind. We're a lot of kind people, and that includes myself. It's hard to say which of us is the most kind. All right, so what do we have left here? We have BC4. Is this another? No, this one's pretty small, right? A, B, C, and D. That's it. Yeah, just A, B, C, D. So yeah, we'll do that Monday. Tuesday will be the big dance. There's some intense landscaping going on outside my window. All right, everybody feeling positive, feeling strong about these tests? Making a notes binder for all of mine with tabs, so if I panic and forget something, I can have little one-pagers. That's nice. I like it, for sure. Seems smart. Reese, do you know what you're gonna... Are you planning on doing your calculus one on your phone or on the computer and transferring pictures to your computer or something else? Are you taking it on your smart fridge? There's a lot of good options. Doing the phone demo today, but it was incompatible with the smart washer dryer set. Well, what's the point? Never mind then. Just throw the whole thing away. Like, if you can't do the whole thing on your smart TV, it's not worth it. Maybe your toaster. Kyler would like you to know before the stream ends that he thinks the math streams are just very strange dreams and collective hallucinations. I'm glad that Kyler needed for you to tell me that, because otherwise there's no way that I would have any interaction with Kyler other than the class that he shows up to every other day. So that's helpful. All right, well, I think I'm going to make a move, head out of here. Hope you guys have a good weekend, and keep doing what you're doing to get ready. Yeah, same stuff. Practice FRQs. Go watch the videos from the AP playlist for BC. Practice memorizing your formulas and such. Organize your notes. Go do the demo from the AP site. Just win. All right. Okay, I'll see you guys back on Monday. We'll finish up this this file for these questions, and that'll be that. Okay. Let me know if you have any questions.